Hello, I'm Tarakesh, assistant professor working as assistant professor in Triple Department in SRIT Autonomous Engineering College. Today we are discussing about the course is DC machines and transformers. DC machines and transformers subject deals with all the DC machines and transformers. In coming to DC machines, we are discussing about DC generators and DC motors, their characteristics, losses and efficiency, and what are the types of DC generators and types of DC motors, and what are the construction aspects of DC generators and DC motors, and principle of operation of DC generators and DC motors, like that. Today we are discussing about the principle of operation of DC machine. Okay. Okay. At the end of the session, we are able to learn about principle and operation of DC machine. This is the general idea of this topic of the subject is electromechanical energy conversion. Okay. In this figure, the input is electrical energy and we are getting the output as mechanical energy and vice versa. Okay. Electrical energy as input and we are getting the output as mechanical energy as a and vice versa. Mechanical energy is input and we are getting a electrical energy as an output. We have to know that in this topic, in an input and output, they are not equal. Okay, because due to some internal losses like I square losses and friction losses, etc. losses, input is not equal to output. Okay, if we are going to convert the energy into another form of another form of energy, we have to use some medium. Here we are using magnetic medium, magnetic field. Magnetic field is used as a medium. Okay. What are the types of electrical machines? We have two types of electrical machines, rotating machines and stationary machines. Coming to the rotating machines, motors, generators, they are the rotating machines. And again, they are divided into two types, AC motors, generators, and DC motors, generators. They are divided based on the supply. Okay. And coming to the stationary type, transformers are the stationary type machines, electrical machines. Okay, because in rotating type we have rotating parts. In transformer there is no any rotating part. Okay, we know that which device which converts mechanical energy to electrical energy, that will be called as a generator. Okay, and similarly electrical energy to mechanical energy, which device which converts electrical energy to mechanical energy, it is called as electrical motor. Okay, what are the types of DC machines? We know that DC motor and DC generator. Okay, coming to the DC generator, it is a generator which converts mechanical energy to electrical energy. You know that electrical energy, but the which form? In which form? This is the DC form of electrical energy, default as a DC generator. Coming to the DC motor, motor is converting electrical energy to mechanical energy. We know that, but it takes which form of electrical energy? DC form of electrical energy. That's why called as DC motor. And what are the types of AC machines? AC generator, which converts mechanical energy to AC form of electrical energy. It generates AC form of electrical energy. Similarly, AC motor, which will take AC form of electrical energy into mechanical energy, is called as AC motor. Sorry, this is the AC motor. What is the working principle of DC machine as a generator? Both DC and AC generator will work on the same principle, that is Faraday law of electromagnetic induction. Okay, Faraday law of electromagnetic induction, which states that whenever a current carrying conductor, whenever a current carrying conductor is placed in a magnetic field, it will generate some voltage that is called as EMF. Okay, you know that you can formulate the EMF formula is E is equal to d phi by dt, which means EMF is equal to the rate of change of flux linkages with respect to the time. But we don't know how many number of turns in the conductor. If we are including the number of conductors also, N is denoted as a number of conductors, number of turns in the conductors. We can include that E is equal to minus N into d phi by dt. But why we are indicating minus sign in this equation? According to the Lenz's law, EMF will oppose the source of it. Okay, according to Lenz's law, any form of parameter will oppose this source of it. That's why EMF will oppose the supply voltage. Then we are including the negative sign. We can learn more about parallel law formula. Here we are using one coil and connected to the one galvanometer, and one magnetic piece also using a magnet is approaching towards the coil. Consider at a two time instance t1 and t2. We can write the flux linkage to the coil at a two time instance. At first time instant is t1 is equal to n into phi1. Phi1 is flux at first instant, n is the number of turns in the conductor. Similarly, flux linkage with the coil at the time of t2 is formulated by n into phi2. And what is the change in flux linkages? That's why it reflected to the change in flux linkages is d phi. Okay, n into phi2 minus phi1. And the change in the flux linkage will be phi is equal to phi2 minus phi1. And similarly, we can note down the n phi by t. But according to the formula of electromagnetic induction, rate of change of flux linkage is equal to EMF with respect to time. Okay. And which hand rule generator will work on the which hand rule? Fleming's right hand rule. Okay. Here we are in this figure, two magnetic pieces are there, and flux will be traveled from north pole to south pole. Okay. And it reflects the generator principle. Okay, generator hand rule. Here we are using if we are using our right hand, thumb will be indicating as motion of the conductor. It will move upwards and downwards, and forefinger it will indicates the direction of the flux. It will travel from north to south, and direction of the flux will be forefinger, and middle finger will be indicating that direction of the EMF or current. Direction of the EMF or current. This is the Fleming's right hand rule. Similarly, motor will work on the Fleming's left hand rule. Okay, generator will work on the Fleming's right hand rule. This is the principle of operation of DC generator. Okay. And next topics we will discussing about the construction of the generator and what are the types of DC generators like that. Today, end of the topic is. Thank you.